Good evening, everybody. I'm Rich Harris. I post on Blue Sky at richharris.dev, and this is Frameworks for Humans in the Age of Machines. I'm here representing a project called Svelte. For those of you who are not familiar, Svelte is a declarative component framework similar in spirit to React and Solid and Vue and things of that nature, albeit with a few philosophical differences. In addition to Svelte itself, we maintain a full stack application meta framework called Svelte Kit, which is our vision for what building robust, accessible web apps should feel like. It is an incomplete vision. We have a lot of work still to do, and some of that work is what I'm here to talk about today. We're here because Sergey and I were hanging out in Amsterdam a couple of months ago at a web performance conference called Performance.now, where I gave a talk called Fine-Grained Reactivity. And we agreed that it would be relevant to share at this meetup. The basic thesis of the talk is that web performance is a physics problem. Essentially, we, especially framework authors like me, have spent a lot of time obsessing over the fastest ways to model reactive state or the fastest way to update the DOM. But the reality is that the biggest problems in web performance are caused by the speed of light and our failure to overcome it. You can watch the full talk by going here, but before I start ranting about the machines, I'm going to give you the short version. We all know that a web app is essentially a distributed system. You visit a URL, you get an HTML document, which will cause your browser to fetch other resources, often from different places. If it's a client-rendered SPA, then before the user sees any content, they will need to fetch some CSS and JS files, most likely from a CDN server near them. Those CSS and JS files might import other CSS and JS files, and they don't do anything until they're all loaded. Once they are loaded, we can start the app, but before we can actually show anything to the user, we probably need to get some data, so the user makes a request to your server. This time, the request cannot be handled by a CDN because the response is personalized, and so it needs to go all the way to your origin server, which could be a long way from the user. The origin server needs to consult a database, hopefully within the same data center, and once it has that, it can respond with the data. But based on that response, the app might need to get more data, and this is pretty common during initialization. Mobile devices these days are generally quite powerful, but latency is still a real problem. So when you have these waterfalls, it tends to result in a really janky user experience. Server-side rendering goes a long way towards fixing this. If you use a framework with SSR like SvelteKit, then the HTML response will have done most of the work already. You have content for the user to look at, you'll have link elements that preload all of the JS and CSS assets that you're about to import, and the response will contain the initial data so that we can turn it into an interactive client-side app without needing to go back to the server. And for static content, you can even pre-render the HTML at build time and put it on a CDN so that it's close to the user. There's a common misconception that you only need SSR if you care about search engine optimization. This is wrong. SSR is about performance and resilience. If you care about performance, if you care about your users, then SSR is not optional, it is absolutely essential. But it's also not the complete solution because it only affects the first load. In many apps, as you navigate around, one of two things will happen. Either components load data independently of each other using effects, in which case you experience loading spinners popping in and out at different times, like a game of whack-a-mole, or you fetch as you render, loading data sequentially as you navigate to a page, and you start hitting those dreaded waterfalls again. So the Svelte team have spent the last year thinking about what problems we're really trying to solve here and what a first principles approach to solving it would look like. Especially given that as a compiler, Svelte has unique capabilities. The problem is this. First, we want our components to be able to manage their own data requirements. Historically, front-end frameworks have dealt with data by loading it outside the rendering process and passing it into components as props, but that's a really limiting approach with a lot of problems. In the same way that components manage their dependencies on styles, JavaScript modules, other components, and so on, a component that can get its own data is much more useful than one that can't. Second, asynchronous work needs to be coordinated. If you have two separate components that get data independently of each other in response to the same user interaction, you almost always want them to update the page simultaneously. We've all seen websites with loading spinners that pop in and out all over the place. It is a really horrible user experience. It's very hard for independent components to manage this stuff among themselves, so it becomes the framework's job, our job, to coordinate everything. Third, we want real type safety. In 2025, it's not enough to get a blob of JSON anymore. Programmers expect to get type checking and autocomplete and inline documentation. But beyond that, when you're passing data between client and server, you need to have guarantees that the data you're getting is the right shape and that your function isn't being called by an out-of-date client, or worse, someone trying to mine Bitcoin on your computer. So validation is very important. Fourth, it should be dead simple to use. No awkward constraints about having to put your reads in server components and your writes in client components. No rules about where you can do async work. Something I believe very deeply is that computers should work for us and not the other way around. And finally, we want it to be fast. We want to eliminate waterfalls. We want to anticipate the user's needs by getting data ready exactly when they need it. We want to minimize the amount of work that needs to happen, both in the browser and on the server. And we want tiny payloads instead of huge blobs of JSON. And we think we've come up with something that is a meaningful step forward. It comes in two parts. Async Svelte is the foundation, which lets you use await inside your components in a way that is automatically coordinated and parallelized. And on top of that, there's a new feature in SvelteKit called remote functions. And so I'm going to switch screens for a moment to give you an idea of what all this looks like in practice. All right, so I have a button, and when I press the button, the counter goes up. Please, hold your applause. And if we look at how it works, obviously we're cheating. This is just some client-side state. In Svelte, this is how you declare state. Maybe I'll make the text a little bigger so you can see it. And then we just assign to it, which causes the component to re-render. But if I reload the page, I lose all of my state, all my hard work for nothing. So what we want to do is get that state onto the server. And in SvelteKit now, under the experimental flag, we have something called remote modules. In this file, count.remote.ts, I'm going to declare my state, let count equals 0. And then I'm going to expose access to this state via something called a query. And now, inside my component, I can get rid of these and do await get count, like that. So now when we load this page, we're getting data directly from the server. Of course, it's not updating because we haven't wired it up to anything. But before we do that, let's look at the code that we just wrote. Some of you might look at that and think, this guy's a bit of an idiot. He just put 2 sequential awaits in the critical path. And it's actually okay in Svelte for 2 reasons. Number one, this get count describes a resource which we know is not changing between these calls. So Svelte can just automatically cache that. The second time it reads that, it just reuses the same promise that was already created. But also, because Svelte is a compiler, we can see that everything inside this template is a pure expression. It's not going to affect anything else. And so we can actually hoist these out and run them in parallel. And so because of that, we get the maximum efficiency without having to do all of the laborious work of taking things somewhere else, giving it a name, doing promise.all, all of that nonsense. Again, the computer should work for you and not the other way around. Let's make this button actually do something. Back in our remote module, we'll add the counterpart to this query, which is something called a command. Export const increment equals command. And this time around, we want to pass some data to it. And whenever you're passing data from the client to the server, it is very important that you know what you're dealing with. You can't have people sending their own data without you checking it, because that way you will get hacked by evildoers. So I'm going to import a validation library called Valibot. You can use any validation library as long as it implements something called standard schema, which is a convention that is used by Zod and Archetype and everything else. And I'm going to specify that the input to this should be a number. And now inside here, we see that D is already typed as number. And we'll just do count plus equals D. Back in our page, get rid of this and replace it with increment by 1. So if I press the button, well, looks like nothing's happening. If I reload the page though, it is actually saving that state to the server. All we need to do is tell the client what's happened. So inside increment, after we have changed the state, we're going to say get count, refresh. So this time, if we hit the button, we will see that the data is coming back. And if we look at the network tab, you can see that it's only one request, and the request includes the command and the resulting change in state. So we're not having this waterfall where you go to the server, tell it what to do, wait for that response to complete, and then go back to the server to find out what changed. It all happens in one go. Of course, this all works well when it's happening on a local machine, but in reality, you're going to have to deal with some network latency. So if we simulate that with an await sleep, you'll see that the experience is a little unsatisfying. We push the button and then nothing happens for a minute. And you can't always make your backend faster, and you certainly can't make the user go closer to your server. But what you can do is fake it. We can defeat the speed of light constraint with something called an optimistic update. After this increment command is called, we'll do increment 1 updates, and then we will tell the page what state change we expect to have happened. So it updates get count with an override. N is going to become N plus 1. So now, as we push it, we get feedback immediately, even though the network activity is happening in the background. And if we were to experience some errors, throw new error. Oh no. Then as we spam this button, the number goes up, but as some of the requests fail, those changes are rolled back. And because it's a reducer, it's possible to have these happen in any order, and the state will kind of fix itself as it goes. All right, let's move on to another demo. I have a weather app here that is showing us it is currently rather cold in New York City. And you'll notice that when I load the page, nothing is happening in the network tab because this page was rendered on the server and all of the data that is needed for this page is included in the HTML payload because we don't want to have to go back and forth if we already know what the client needs. If I click on Paris to expand it, then I get another request just for the data for Paris. But then if I hit show all, I get 3 more requests for New York and Amsterdam and Singapore. That's not terrible. Like, it's okay with HTTP2 to have multiple requests in flight, but what's not so great is that those requests will all hit the server independently and cause individual API requests on the back end. And that's something that you definitely don't want because that's going to count towards your quota, is going to cost more money and stuff. So it's better if we can avoid that. So let's have a look at the forecast component and see if we can fix it. Okay, so we're getting this data from a query, like the one that we saw in the previous example. And it's pulling this data from an external API. And what we want to do is batch it up so that all of the queries that happen at the same time get rolled into one. And we can do that with query.batch. This time around, instead of being passed an individual city, we're going to be passed an array of cities. So I'll pass that to the API, and then we'll stop destructuring it. And then instead of returning the data, we're going to return a function that for each item in that sitters array returns the data associated with it. So if I remember this right, it should be something like c.latitude is equal to, no, we want to do data.find d.latitude equals c.latitude. And if I was being thorough, I'd do the same for longitude, but I'm not. And this time around, if I refresh the page and I get Paris again, it's in one request, and if I hit show all, hopefully it's going to be in just one more request. Okay, so we get the best of both worlds, and we haven't had to resort to something like React Server Components, where you render the stuff on the server and then send it back, at which point it becomes really hard to integrate client state that interweaves with your server components, for example, if you want to toggle between Celsius and Fahrenheit. So this is kind of the best of both worlds in our view. Has anyone seen a to-do app before? Has anyone seen the sequel to the to-do app? To-do, to-do. All right, who here, as a web developer, works with forms? Who here as a web developer likes working with forms? So there's a lot fewer people, and I get it, forms kind of suck. They're very complicated. There's a lot of things that you need to consider in order to get them right. And we think that we've developed a pretty nice abstraction for dealing with this stuff. So I've got a login form here. And if I go to my editor, we can see what's going on here. We have a form element, and we are just spreading this login object onto the form. That object contains the method equals post, the action equals whatever URL the data is going to get sent to, along with an event handler that is going to deal with the form submission in a progressively enhanced way. Instead of reloading the page, which is the default behavior of forms, it's going to get the data, and then it's going to gracefully update the page without a reload, unless JavaScript isn't working or is disabled for whatever reason, in which case it will fall back gracefully to the default form behavior. And inside the form, we have inputs for the email and the password fields. And these come from the schema that we created with Validbot. We go to the implementation of this, v.object, we've got an email and a password and an action which can be either login or register. So again, we know exactly what we're dealing with inside this handler when it runs. It's all type safe and it will all be checked on your behalf. This underscore here, this denotes a private field. If you don't have JavaScript running and you do get a full page reload, if the form was invalid, like the data didn't have like the right password or whatever it is, then you want to have as much of the form repopulated as possible. It really sucks if you submit a form, there's an error, and you have to fill out the whole damn thing again. So we send it back, we send it back in the page when that happens, but we don't want to do that with sensitive data like passwords and credit cards and stuff. It's honestly probably fine to do that, but as an abundance of caution, some people really don't want to, and so this gives you an out. And because we have this strictly typed set of inputs, we can fill out these with we get all of the autocomplete and type safety, and this field contains the name and the value and the aria invalid attribute, so that if something goes wrong, people who are using your site with screen readers and other assistive technologies, they find out about the validation error too. And if you had to do all of that yourself, it would end up being like a ton of code. And this is just way, way, way less code. So if we try and log in here, and I'll put my password. Oh, password is too short. So it's given us the validation error. It's added the aria invalid attribute, and we're using that aria invalid attribute to style the, whoops. Go away, agent. Not yet. You're later in the talk. We're using that to do some CSS. But if I get the password right, then we can log in and we can start adding some to-dos. So I'll add one with different priorities, like that. And of course, this would all work without JavaScript, but because we do have JavaScript, we get nice springy effects and other pointless things. Let's take a look at the implementation of this form. It's a little bit more complicated than the previous one. But before, we just had two fields. We had email and password and an action. But this time around, it's a bit more complicated. We have this nested object here, attributes.priority. And priority is a numeric value, which can be between 1 and 5. And because it's a numeric value, we have the ability to say that if we do this as like text or something, we'll get a type error because you can't have a text input for a numeric value. Instead, it will tell you it can be a number or it can be a range. And as we waggle that around, we see that the number next to it actually updates because all of the fields in your form update reactively. And we can do all this sort of thing too. Let's try toggling it to do. Ooh, that was a little bit slow. How about this one? Let's see why it's so slow. So we have this toggle form here, which is an instance of the toggle to do for a specific ID. Oh, I found the culprit. We have another one of these. Well, we could just get rid of it and just make the back end magically fast, but you don't always have that ability. So instead of that, let's try and fix it on the front end with an optimistic update instead. It's going to look something a little like this. We're going to enhance the submission. Gets passed in a callback. So we'll do, let's see, submit. And then just like the command before with the button, we'll do the submit updates, the to-dos with an override. The to-dos, to-dos get passed in. And then we want to return, this is complicated, bear with me. If it's the current to-do, then we want to invert the done state. Otherwise, we can just return the data as is. And so now, if I've done that right, we can just update that immediately. And you can see, again, in the network tab, as we do this, the network stuff is happening in the background, and it just resolves as things shake out. So hopefully forms are about to get a little bit less soul-sucking. But at this point, I am going to go back to my slides and move on to the next bit. So in the full talk, I also discuss React server components a bit, and I throw some shade at the conventional wisdom in web performance circles. So if that is your bag, then by all means check it out. For now though, I do want to shift gears a little bit and start talking about what is rattling through our heads as we think about what work we on the Svelte team want to get done in 2026. So back in 2018, I introduced Svelte to the world at JSConf in Berlin in a talk called Computer Build Me an App. And the thesis was this: we were transitioning from a world in which people wrote painstakingly imperative instructions for the browser to one in which developers use high-level abstractions that computers then convert into low-level instructions. I had no idea just how right I was. I could not have predicted that in 2026, the high-level declarative abstractions would be plain English, that they would be turned into code by AI agents, or that those agents would be threatening our entire industry. I feel like Switch in the Matrix, knowing the end is nigh, saying, not like this. The Matrix, of course, is a series of films in which humans are trying to survive in a world of agents. Sometimes the agents go rogue and do things they weren't supposed to. Later on, they learn how to create sub-agents until eventually the entire world is just agents. It's worth remembering, of course, that the real villain of the first Matrix movie wasn't Agent Smith, it was Cypher, a man who sold out the human race for power and riches. Does that remind you of anyone? All right, so let's talk about the AI landscape. There was some real drama last week. Anthropic decided that you can no longer use your Claude subscription with third-party agents like OpenCode. You have to use API access, which is an order of magnitude more expensive, or you can use Claude Code instead. I don't have much to say about the rights and wrongs of this, but it was a really good reminder that when you use these tools, you do so at the pleasure of Dario and Sam and Elon. Let's talk about Elon. A year ago, he illegally dismantled the US Agency for International Development. The Lancet, which is one of the world's most prestigious medical journals, published a paper last July estimating that millions of people will die prematurely each year as a result of the richest man in the world cutting off their access to food and medicine. But he's not just one of history's greatest monsters, he's also one of the saddest, most pathetic men to have walked the face of the earth. He got so mad that Grok kept fact-checking him that he forced it to become a sycophant, but because he or his lackeys did it so ineptly, it resulted in things like this. This is incredibly embarrassing for everyone involved, but it also hints at the dangers of mediating the world's information through models that can be controlled by powerful individuals like Elon Musk. How might these risks play out in the realm of software? Well, imagine you use a particular LLM day to day. Perhaps it's the one that your company has an enterprise subscription for. Perhaps it's just the one that you've had the best results with. What happens if one day you try to build an app that competes with one by the company that provides that model, and instead of doing it, the agent says, "I'm sorry, Dave, I'm afraid I can't do that." Or what if you need a tool to download YouTube videos or scrape a website for legitimate journalistic or archival purposes, and the agent says, "I'm sorry, Dave, I'm afraid I can't do that." It's not so far-fetched when Google owns both YouTube and Gemini, and OpenAI and Anthropic have multi-million-dollar contracts with providers of content. In 2019, protesters in Hong Kong used an app called HK Map to track the police. One day, it was removed from the App Store at China's behest because Apple, like most giant corporations, is often both self-interested and spineless. If you're building an app used to industrialize the sexual harassment of women and children, go right ahead. If you're building an app to protect your neighbors from a repressive regime, you're on your own. Luckily, those protesters were able to use the web-based version because the web is permissionless and much harder to take down. But what if you can't even build the software in the first place? What if you're trying to build an app to protect your neighbors from a repressive regime, and the agent, which is controlled by men who have pledged fealty to the regime, says, "I'm sorry, Dave, I'm afraid I can't do that." Or maybe the models don't prevent you from building certain kinds of software, but they do expose you to constant passive surveillance, where model providers are able to say, "These are the people building ICE monitoring software in New York City." I don't trust this man not to sell me out to the feds, and nor should you. I certainly don't trust this guy. You might think this all sounds a bit alarmist, but I really don't think it is. To me, this seems like a fairly gentle extrapolation from the world we live in today. But there is a solution, and I am not talking about Butlerian jihad, for those of you who know what that is. We need models that are open source, open weights, and can run on hardware you control. These things exist, but they are kind of niche, and the models that can run on a typical laptop are far behind the proprietary state of the art. And the villains in our story want to use fear-mongering to try and keep it that way. But that's what we need to fight for. It is nonsense to say that AI is democratizing software as long as the models are not democratically controlled. Right now, our industry is sleepwalking into a bad situation. The freedom to write and distribute software without interference from governments and corporations is intrinsically linked to all of our other freedoms. And yet, I regret to inform you that the proprietary state of the art is shockingly good. You might have noticed a bit of a vibe shift in the discourse over the last couple of months, particularly around Opus 4.5, which is Anthropic's flagship model. So while we're waiting for the open models to catch up, let's talk about where we are today. There's been a change of heart among a lot of people like me who, beyond the ethical concerns and the environmental concerns and the economic concerns, have been ignoring LLMs because they just weren't that useful. They're impressive, certainly, and unexpected. It is genuinely astonishing that if you put all of the world's text into a giant blender, you get a model that produces coherent output. But it would also be genuinely astonishing if you taught a horse how to juggle. It doesn't mean there are any practical applications for a juggling horse. But with Opus 4.5, we have soared over that usefulness threshold. If you haven't been paying attention, I'm afraid it is time to start paying attention. So the question for framework authors is, what do we do now that the dream of computer build me an app has come true? Well, the good news for people like me is that frameworks are more relevant than ever. When LLMs first came onto the scene, a lot of people predicted the death of high-level abstractions. It was assumed that LLMs would just code directly against the platform. That has not been the case at all. Agents thrive in code bases with strong conventions and clear structure. They love having patterns to follow, mature documentation, type safety, and all of the other things that you get with frameworks. That said, there are some headwinds. Firstly, smaller frameworks like Svelte are not well represented in the training data. And what does exist is bias towards older versions with deprecated features. And as with all frameworks, not to be rude, but there is a range of skill levels represented in that code. So there is a bit of a gravitational pull away from modern, accessible, high-quality Svelte code. There are some levers we can pull. We don't have much influence over technology choices. If you leave it up to the agent, it will probably choose React. But we can influence what happens if you're using an agent in a Svelte codebase. For example, we have an official MCP server built primarily by Paolo Ricciuti on our team that runs alongside your agent and gives it the ability to fetch up-to-date documentation and to run the code it generates through a deterministic process that fixes common mistakes. This goes a long way toward enforcing modern best practices, and it will report things like accessibility violations back to the agent so that it can fix them. This week, I gave myself the challenge of building an actually useful SvelteKit app from scratch without writing a single line of it. I started by creating a blank project with SV, our CLI, and telling it to set up the MCP server for Claude Code. Then to do the actual development, I used a tool called Dev3000, which is built by Lindsay Simon, who's my boss at Vercel. Dev3000 or D3K starts your dev server, starts your agent, starts a monitored instance of Chrome, and then gives the agent access to everything happening in the dev server and the browser so that it can see logs and check accessibility violations and monitor network activity and so on. It's extremely cool. And this is the result. It is a two-factor authentication app called Tufa. I have this installed on my phone as a progressive web app. And I also use it on my laptop. Anytime I want to log into something like GitHub, which needs a 2FA code, I can use biometric login to access my vault. Please work. And my vault is encrypted using my password, my passphrase, and all of my secrets are stored on device. And I can add new accounts via QR code. Let's see if this works. So first of all, I'm going to create a vault. Let's call it default. Give it a passphrase. Whoops. And then to add an account, so I can bring up the account on my phone, reveal the QR code. It's going to ask for my fingerprint again. And then now, if everything has worked correctly, it's going to see my, here we go, okay. And then it's going to give me the option to save that, which I don't want. And before I was using this, I was using an authenticator app called OneAuth, which died on me just before Christmas. I managed to export my secrets just in time, otherwise I would be completely screwed. I wouldn't be able to log into anything. But because of Twofer, I'm no longer reliant on someone else's servers, and I feel so relieved about that. And I want to emphasize again, I didn't write any of this, not the encryption, not the one-time password generation, not the biometric login, not the UI, not the test suite. None of it. All I did was write issues on GitHub and ask it to open pull requests while I spent way too much time designing a logo. That's not to say it did everything flawlessly. Once the app was feature complete, I audited the code base and I wrote up my findings in this issue. In response, the agent opened a dozen sub-issues for the things that I'd identified, and then a bunch of PRs fixing those sub-issues. And it's really cool to see how with a tiny bit of prompting, it was able to make some substantial improvements to the code base to make it more maintainable. Take this PR, for example. By using the new experimental async capabilities that I demoed earlier, it was able to get rid of this convoluted effect code and replace it with something that will be much more maintainable for the agents or humans that maintain this code in future. And the UI is also better because using await here prevents flickering when we go to this screen. So I was able to guide the agent towards eliminating some of the technical debt that had accumulated. And it's possible that this is just another one of those things that agents will get better at over time, but I suspect there's a little more to it than that, partly because best practices are constantly evolving, partly because LLMs want to generate text. That's what they do. And all the examples of code in the training data are by definition stuff you add. But it took a lot of work to produce that audit. And I don't mean to brag, but I have been writing Svelte for longer than anyone else on the planet. So I don't expect every Svelte developer to be able to produce that kind of audit. It would be a lot better if we could steer agents away from making those sorts of mistakes in the first place. So how might we do that? Well, some of it could potentially be delegated to the MCP server so that it happens as part of the auto-fixing loop I described earlier. But a lot of the things that agents struggle with aren't necessarily things that you can easily find with static analysis. They're a little bit more nebulous, like don't overuse effects or use classes for state management. Knowing these rules of thumb is what you might call a skill. And sure enough, agent skills are all the rage right now. A skill is basically a markdown document that provides your agent with some domain-specific expertise. An example of this is the React best practices skill that Vercel released this week. It includes the accumulated wisdom of some of the world's best React engineers, and the best part is it isn't exclusive to LLMs. Anyone can read it and learn valuable stuff. It's likely that we'll end up producing something similar for Svelte, and just to make all of this relevant to this meetup, that will include web performance guidelines. Another way that we can help agents is by improving the docs. It used to be the case that you'd have some reference docs and a getting started guide, but a lot of the more advanced real-world content lived elsewhere in courses and blog posts and YouTube videos and even Twitter threads. That doesn't really cut it anymore. The more you can do with your primary documentation, the more successful your agents will be. One thing that we've talked about on the team is having lots of short FAQ style, how do I do X type snippets with code samples that agents can crib from. And again, this is something that we know humans will benefit from too. By solving LLM-centric problems around completeness and discoverability and limited context windows, we are forcing ourselves to get better at thinking about how to answer people's questions as well. Svelte already does a pretty good job of emitting errors and warnings when something goes wrong, and agents do a pretty good job of heeding those warnings. But I suspect we can do a lot more here. This code fails to compile because we're using TypeScript syntax, which agents love to do. Instead of complaining about a generic parse error, what if the error message told the agent exactly how to fix it? Once again, this is something that would also be useful for meatbags like us. You can probably see a theme developing here. Another thing that would help is to be more opinionated about libraries and integrations. This is slightly controversial territory because as a framework, we don't really want to be in the position of picking winners or having first-party solutions to everything that crowd out innovation in the ecosystem. But the reality is that things go a lot more smoothly when you have smart defaults around things like auth and persistence and internationalization and UI. Some ecosystems have really nailed this, though we in the JavaScript world tend to lag behind a bit. We've made a start by promoting some of the best packages on svelte.dev, but there's definitely more that can be done here. Whoever first gets this right will develop a lot of goodwill with both man and machine. Okay, a lot of you have probably memory holed the Matrix sequels, which is fair. They are difficult films to love. But here's what happens at the end of the trilogy. The humans don't win the war against the machines. The artificial intelligence is not vanquished. Instead, we form a truce with it. And as much as part of me yearns for a Butlerian jihad, I think that would be the right outcome for us too. Svelte continues to be an unapologetically human-centric framework. It is a community of people with spiky opinions and stupid in-jokes and a deep-rooted skepticism of Silicon Valley fads and tech bro obsessions. But it is also a tool for people who want to ship and a project that wants to enable the largest number of people to be part of the web as creators rather than just as consumers. So to paraphrase the old Slashdot meme, I, for one, welcome our new robot colleagues. Thank you for listening.
So when you built your to-do app with AI, at the end of it, how did you feel your understanding of that app compared to when you traditionally hand-built it?
It definitely was not as thorough, no doubt about it. And I've been trying to grapple with the question of whether that matters or not. There are certain parts that you definitely do want to understand. Like this is essentially like a security app. I don't want to like not review some vibe coded code that's encrypting my secrets that if someone gets hold of my phone, they're going to be able to log into my entire digital life. And so I gave that fairly close scrutiny, but after a while, I realized I was just kind of rubber stamping a lot of stuff. Once it had gone through that audit and improved the state of the code base, I was like, you know what, you got this. And that has been kind of shocking to me as someone who's been very skeptical of these things for a very long time. Like it's as good as, you know, a lot of developers that we work with day to day. So if you're used to reviewing pull requests from other humans, then you know how you get like a 400-line diff and you're like, yeah, it's probably okay. Like it's the same thing. And honestly, one of the things that I've sort of forced myself to come to terms with is that a lot of the code bases that I work in, I already don't have a complete understanding. I know the bits that I wrote. Like I spent the time going on the mental journey of figuring out exactly what this abstraction is supposed to look like or whatever it is. But when it's a PR that someone else wrote that I'm reviewing, like I will try and get into the right headspace, but it's like you're kind of skipping over the steps that produce that code in the first place. And so I'm trying to think of these things as colleagues, as opposed to like this mysterious new kind of thing. And I'm okay with not understanding every single line of code on that basis.
Okay, my question actually. Will these things produce faster user experience, you think?
I think they can, yeah. Like we touched on this idea of skills at the end, and the React best practices skill is one that includes a lot of advice around avoiding waterfalls, for example, and some of the other things that are commonly found in React code bases that cause apps to become slow. So you can sort of distill that expertise and make it a thing that you can npm install, like npm install performance expert, npm install accessibility expert. You can npm install a designer. And so I'm actually pretty optimistic that if we're careful and we embrace these things the right way, that it could actually improve the median, like the quality of the median code base and the user experience of the median code base. It's far from guaranteed, but I like to believe it could happen.
Yeah, so I guess after this experiment you've done, how do you think it will affect your development in the future? Like how you kind of go forward?
Anytime I'm building an app, I'm 100% going to go this way. Because like, I never write tests for my apps. Are you kidding? And it just did it. It like spat out a whole bunch of unit tests for the encryption and the one-time password generation. And then I said, okay, can we have some end-to-end tests too? And it was like, sure, Huss. Like 30 seconds later, it's installed Playwright and I've got like the whole soup to nuts thing. The only thing it doesn't test is the QR scanner, because like how the hell would you do that? But the rest of it, it was good. Like I looked at the tests, they're good tests. I wouldn't have done that. So every time I'm building an app, I am doing it this way from now on. Luckily, I get to use Vercel's enterprise subscription, so I don't have to pay for the tokens. If I did, maybe I'll be a little bit more careful. But yeah, I just don't see why I would do it any other way. However, as I'm working on Svelte itself, I'm going to be a lot more careful about where I let LLMs run loose, because, you know, almost by definition, if you're working on a library, you're trying to solve a new problem. Like you're trying to expose some new abstraction or some new idea. And so that kind of doesn't exist in the training data, or you would hope. Like if it does, then maybe you're wasting your time and you should like just use the existing library. People tell me that all the time, but whatever. And so like the stuff that we've been working on over the last year in particular, this stuff around asynchronous coordination, it feels like a little bit like we are breaking some new ground. We're solving these problems in a way that is different to the way that React solved these problems, a different way than Solid solved these problems. They're now looking at our solution and thinking, maybe we want to be more like them. So there's like a conversation happening outside the sphere of knowledge that LLMs are strong at. And so for that reason, it's probably going to be a while before I let Claude Code use loose on this. But we have had some PRs that were done with Claude, and they've been good PRs. So you know, as long as we're careful about reviewing them, then I'm certainly not going to say like we'll have a policy against it or anything. But it's just not going to be my first port of call when I'm trying to fix issues in Svelte.
Hi. Thanks for the presentation. I was fortunate enough to work at a company actually in this building that had a site, their marketing site built in SvelteKit, and really enjoyed the experience. And when I left the organization a few months later, it turns out that since the main application was built in React, they were like, or somebody up top was like, hey, we should just use LLMs to convert this all into React, and have it be in one platform. Their core web vitals did take a plunge at that moment.
Many such cases.
But I appreciate the take on how do we enable LLMs to actually use this tool, because we don't have as broad of an ecosystem of source data. But you're still up against the inherent, hey, you can hire engineers that are React. There's like a large talent pool. There's the kind of there's the there's the the talent pool issues that the management layer is like just, hey, we know React, this is the thing we're going with. Like, not that you necessarily can't form a truce with React as existing, but like, I don't know, is that something you're thinking about in terms of like the skill sets that are already out there in the inertia that the React ecosystem has, and like how do you differentiate yourself?
I mean, there's so little that we can do about the job market, other than like hopefully increase the number of people you want to build with Svelte. The way that I would think about it is that because everyone's using React. If you are using one of the other frameworks, and it may be Svelte, maybe it's Solid, maybe it's something else, like that is a competitive advantage, not only in terms of the product, Core Web Vitals will probably be better, but also like anecdotally, I've heard of people saying that because our code base is written in Svelte, we've been able to hire higher quality applicants, because, you know, everyone who's still wet behind the ears, like day one, they're learning React. The pool of people applying for Svelte jobs is, you know, generally a little bit more experienced. But the way that AI is going to affect this, I would say, is that it matters so much less what you're familiar with. Like if I can, in 20 minutes, implement biometric auth, having never done it before because Claude knows how to do it, then why would I not be able to jump into a React code base or even, you know, a Rust code base and have it guide me around to the point where I'm being productive quite quickly? So maybe this is just wishful thinking on my part, but I would love to see in this era of LLM-powered development, hiring managers be like, you know what, who gives a shit what frameworks people have experience with? Like, are they good engineers? Do they have good common sense? Do they care about the right things? If so, they'll figure it out. And who knows, maybe that's what will happen this year.
I'm curious, you said that you needed to work out how to test the QR scanner. I'm wondering if your AI has already opened an issue for that and working on trying to solve, because you said you couldn't solve it. So I guess it's just a never-ending sort of feedback loop. It's just funny how you sort of said, like, we don't know how to, you know, I don't know how to do that part, but shouldn't your AI be working on it?
I mean, the thing is, like, you don't have cameras in CI. You know, so I just don't exactly know how you would do like a test of someone holding a QR code in front of the camera. And so, like, yeah, you can like mock it somehow, but then what you're actually testing, it just seems a little bit pointless. And so when I told the agent, please make a test suite, I actually said, like, we should be able to test all of the user flows apart from probably the QR scanner, because I have no idea how you would do that. And it was like just echoing my words back to me, but it was like, yeah, I have no idea how I would do that. If anyone does know how you would do a thing like that, then I would love to hear it, and I'm sure Claude would too, but yeah, I don't know. That is, I mean, I guess that is where humans still provide some value, like when you do have those gaps, like it's easier for us to go away and research and ask our coworkers. But yeah, I probably should figure it out.
Maybe, like, you know, memes where ChatGPT talks to ChatGPT. You can have two laptops with clouds talk to each other and show something on the screen.
Yeah, maybe.
You scan your QR code.
What do you think is keeping the bot from just outputting WebAssembly? Cut out the middleman, no frameworks.
The training data.
Fine.
Yeah, I mean, it's been interesting. Like a lot of people said, you know, these things, they're just going to write DOM APIs directly. Like, why would they bother with all of this junk in between? It's so much easier for them to just use the platform. And it just hasn't been true. And I don't know what's going on inside the mind of an LLM, but it seems that they really like abstractions. Like, they like things where there are lots of examples to follow, lots of documentation, all of that stuff. And I just don't think a lot of that stuff exists for WASM. Maybe that'll change. Like, maybe as more people use WASM for various things, it will be able to do that. But at least my understanding is that as of right now, it's just not very good at it. And that's also true, I believe, for some of the less well-used languages. Like, it's really good at TypeScript because there is so much TypeScript, but if you like try and have it write COBOL or something, then like there's not a lot of COBOL on GitHub.
What about like Windows binary? There's plenty of examples of that.
But like, do those examples have like comments explaining like what the bytes do? Like, I don't think it can sort of decompile it and be like, oh yeah, it's this byte range is the thing that corresponds to whatever. Like, I just don't think that that is what something that is inherently language based is going to be good at. But I'm kind of talking out my ass because like I don't really understand how these technologies work. I'm just here using them. But yeah, that's my sense.